Let's talk about exponents. And first of all, what is an exponent? Suppose I have 3 raised to the power of 2 or x raised to the power of 3. An exponent, and you might hear the word power, you might hear the word index, exponent, power, index, same thing. What does this mean? 3 raised to the power of 2, 3 squared, is 3 times itself twice. So an exponent is how many times you multiply a number by itself. You know, x raised to the power of 3, x cubed, x times x times x, that's what it means. And in this case, 3 is called the base. X is called the base. So the base is the number that you're raising to an exponent. And then, of course, 2 is an exponent, 3 is an exponent. So that's the gist of it. That's the gist of it. But let's dive a little more into this. 3 raised to the power of 1. Anything to the 1 is just the number itself. So 3 to the 1 is 3. 3 raised to the power of 2, 3 squared. So we said 3 times 3, so of course that's 9. 3 raised to the power of 3, 3 cubed as you would say. 3 times itself 3 times, so that's 9 times 3, that's 27. How about 3 to the 0? 3 to the 0 is 1. Anything to the 0 is 1. You know, 1/3 to the 0 is 1. Even negative 1/3. Negative 1/3 to the 0 is 1. 0 to the 0 doesn't exist, but you would never see that on a test. But anything else to the 0 is just 1. So let me erase that. How about 3 to the negative 1? If you see the negative sign, write 1 over. It's 1 over 3 to the positive 1, or just 1 over 3. Here, I'll erase the 1. So it's just 1 over 3. 3 to the negative 2 is 1 over 3 to the positive 2. It's 1 over 9. It's 1/9. So negative exponent doesn't make the number negative. It doesn't make the result negative. It just means you're creating a fraction. That's what it means. And, you know, 3 to the negative 2 is what? It's the reciprocal of 3 to the positive 2. It's the flipped over version. It's not 9, rather it's 1 over 9. Okay. How about raising 10 to an exponent? So 10 to the 1, of course, is just 10. 10 raised to the power of 2, 10 squared is 100. 10 cubed, 10 raised to the power of 3 is 1,000. So when you raise 10 to an exponent, the exponent represents the number of zeros that follow the number 1. So 10 to the 1, 1 followed by 1 0. 10 squared, 2 zeros, 1,000, 3 zeros. How about 10 to the 0? Well, we said before, anything to the 0 is 1. So 10 to the 0 is what? It's a 1 followed by 0 zeros, no zeros at all. How about 10 to the negative 1? That's 1 over 10 to the positive 1, 1 over 10, 10 to the negative 2, 1 over 10 to the positive 2, 1 over 10 squared, and that, of course, is 1 over 100. So let's generalize all of this. X to the 0 is 1, x to the 1 is x itself, x squared is x times x, okay? X to the negative 1, 1 over x to the positive 1, 1 over x, x to the negative 2, 1 over x to the positive 2, 1 over x squared, and here again, x to the negative 2 is the reciprocal, the flipped over version, the reciprocal of x to the positive 2. And one last thing before we move on, how about raising the number 1 to an exponent? 1 to the 0 is 1, 1 to the 1 is 1, 1 squared is 1. How about 1 to the negative 1? It's 1 over 1, so that is also 1. 1 to the negative 2 is 1. So 1 raised to any exponent is just 1. Suppose you raise a negative number to an exponent. So suppose we have negative 3. Negative 3 to the 1 is just the number itself. It's negative 3. But negative 3 squared, negative 3 times negative 3, that is positive 9. Negative times negative is positive. Now negative 3 cubed, well, that's the same as what? That's positive 9 times negative 3. So now we're back to negative territory, negative 27. But then negative 3 to the 4th is the same as negative 27 times negative 3. So now we're back to positive. That is a positive 81. How about negative 3 to the 0? Well, we said anything to the 0 is 1, so that's just 1. Negative 3 to the negative 1, that's 1 over negative 3 to the positive 1. It's just 1 over negative 3. How about negative 3 to the negative 2? Well, that is 1 over negative 3 to the positive 2. Negative 3 squared, so that is 1 over 9. And so here again, Negative 3 to the negative 2, that is the reciprocal, the flipped over version, the reciprocal of negative 3 to the positive 2. So you want to be on the lookout for this. If you take a negative number and you square it, it becomes positive. And if you raise it to the power of 4, it becomes positive. And the power of 0 becomes positive. And the power of negative 2, it becomes positive. So if the exponent is an even number, the number becomes positive. One last point on negative numbers raised to an exponent. You see here I have negative 3 squared. We said that's positive 9. But suppose I simply write negative 3 squared where I do not have the negative 3 in parentheses, in brackets. That is the same as negative 3 squared. It's only the 3 in parentheses, which is the same thing as what? It's the same thing as negative 1 times 3 squared. So negative 3 squared is negative 9, negative 9, negative 9. That might come up once in a while on a test. Let's talk about exponent rules. Suppose you had 3 squared times 3 cubed. What's that? So the exponents are different, but the number is the same. The base is the same. They have the same base. Well, let's see. 3 squared is 3 times 3, and we're multiplying that by 3 cubed, which is 3 times itself, 3 times. So we have 3 times itself 5 times. We have 3 to the 5th. We have 3 to the 2 plus 3. You add the exponents. So suppose I had 10 to the 3rd times 10 to the 5th. I'm not going to write it all out, but you add the exponents. That's 10 to the... So as a general rule, any number, let's call it x, raised to a certain power, raised to a certain exponent, times, let's say x is raised to a different exponent, x to the a times x to the b is equal to x to the a plus b. You add the exponents. So that's a very, very important rule to remember for a standardized test. If I go back to this example above where I had 10 cubed times 10 to the 5th, suppose I change this a little bit. Suppose I ask what is 10 times 10 to the 5th? Well, 10 is the same as 10 to the 1. So here again, you're just adding the exponents. 10 to the 1 plus 5, that would be 10 to the 6th. Let's look at a little bit more complicated example. Suppose I had x to the a times x to the b plus 2. And I could put parentheses around that or not, it doesn't matter. But same rule applies, you add the exponents. So that is x to the a plus b plus 2. Suppose I had x to the a times x to the a plus 2. Well, a plus a is 2a, so this is x to the 2a plus 2. Suppose I had 3x squared times 4x to the 4th. Well, that's the same thing as 3 times x squared times 4 times x to the 4th. So I could manipulate this a little bit. I could move this around. That's the same as 3 times 4 times x squared times x to the 4th. In other words, I want to focus on the numbers first and then the variables second. Well, what's that? 3 times 4 is 12. And then x squared times x to the 4th, you add the exponents, is x to the 6th. Let's talk about distributing. What's that? Suppose I had x squared times, you would say the quantity, x cubed plus x to the 4th plus x to the 5th. The quantity means everything is put inside the same parentheses. Well, remember distributing? This is the same as x squared times x cubed plus x squared times x to the 4th plus x squared times x to the 5th. You distribute the x squared. So x squared times x cubed, that's what? X to the 5th plus x squared times x to the 4th is what you add. So x to the 6th plus x squared times x to the 5th is x to the 7th. So those are the same thing. That's distributing. And you're just applying the rule that when you multiply two numbers that have the same base but different exponents, you add the exponent. How about dividing numbers that have the same base? So suppose I had 3 to the 5th divided by 3 squared. That's the same thing as 3 to the 5th over 3 squared. What's that? Well, in the numerator, I have 3 times itself 5 times. And in the denominator, I just have 3 times itself twice. So what do? I can cancel 2 3's on the top, 2 3's on the bottom. I'm left with 3 to the third. I am left with 3 to the what? To the 5 minus 2. So when you divide, you subtract the exponent. So as a general rule, x to the a divided by x to the b is x to the a minus b. You subtract the exponents, another very important rule to memorize. Suppose I had 10 raised to the power of 4, 10 to the fourth divided by 10. Same rule, you subtract the exponents because 10 is the same as 10 to the 1. So this is 10 to the 4 minus 1. This is 10 cubed. This is what? This is 1,000. Suppose I had 10 to the negative 2 divided by 10 to the negative 4. Well, we're going to subtract exponents, so that is 10 to the negative 2 minus a negative, so minus a negative 4. Well, you may recall minus a minus is plus, so that's the same thing as 10 to the negative 2 plus 4. That's the same thing as 10 squared, 10 raised to the power of 2, 10 squared. One thing I want to point out, let me go back to my example of 3 to the 5th divided by 3 squared, 3 to the 5th over 3 squared. This division rule, it's really the multiplication rule stated in a different way. So 3 to the 5th over 3 squared, well, that's the same thing as 3 to the 5th times 1 over 3 squared. But 1 over 3 squared, that's the same as 3 to the negative 2. So really, we're applying the addition rule. 3 to the 5th times 3 to the negative 2, you're adding the exponents. So that's 3 to the 5 minus 2, that is 3 cubed. So really, x to the a divided by x to the b is the same thing as x to the a times x to the negative b times x to the negative b, so it's x to the a minus b. And as one final example, suppose I had 8x to the 7th divided by 2x squared. So what's that? Well, 8 divided by 2, 8 over 2 is 4. And as far as the x's, we apply that rule. It's x to the what? 7 minus 2. So x to the 5th. Let's talk about raising an exponent to another exponent. Suppose I had 3 squared cubed. So that's what? That's the same as 3 squared times itself. 3 times. So 3 times 3 times 3 times 3 times 3 times 3. Well, that is what? That is 3 times itself 6 times. That's 3 to the 6th. It is 3 to the, not 2 plus 3, but 2 times 3. So as a general rule, x to the a raised to the power of b, you multiply the exponents. X to the a times b, x to the ab. Very important rule to remember for a standardized test. Suppose I had 3 squared to the negative 3. Well, same rule, you would multiply the exponents. That's 3 to the negative 6, which is what? That's the same as 1 over 3 to the positive 6. 1 over 3 to the 6th. How about x to the a raised to the negative b? So that is what? That is x to the negative ab. That is 1 over x to the ab. 1 over x to the ab. One last thing I want to point out, you might see this in a very hard problem on a test. Suppose you had, we said if you had 3 squared cubed, that's simply 3 to the 6. You multiply 2 by 3. You multiply the exponents. But suppose you saw 3 squared cubed. Suppose you saw that. Since the 3 squared is not in parentheses, that is the same thing as 3. You deal with the exponents first. So that is the same as 3 to the 2 cubed, and 2 cubed is 8. 2 times 2 times 2 is 8, so that's the same thing as 3 to the 8th. That would only come up on a particularly hard question, but it's a good thing to be aware of. Suppose the numbers you're multiplying together have different bases, but the same exponents. So suppose you had xy, x times y, xy, all raised to the power of a. That is the same thing as x to the a times y to the a. So if I had 2 times 3 squared, that is the same thing as 2 squared times 3 squared. That is the same thing as 4 times 9. That is 36. And one thing I'll point out, Suppose that 2 times 3 squared, so that's the same as 6 squared, and 6 squared is what? It's equal to 36. So that all matches up. Suppose I had 2 cubed times 5 cubed. Well, I could rewrite that. That is the same thing as 2 times 5 in parentheses, that whole thing cubed. So that's what? 10 cubed? That is the same as 1,000. Suppose I had 4x cubed squared. One base is 4 and the other base is x. I'm squaring the 4 and I'm also squaring the x cubed. So this is the same thing as 4 squared times x cubed squared. This is what? This is the same as 4 squared is 16. 16 times x to the 6th. Suppose I had 2 times y to the negative 2 cubed. So that is the same as 2 cubed times y to the negative 2 cubed. That's the same as what? 2 cubed is 8. Y to the negative 2 cubed, you multiply the exponents. That's y to the negative 6. So 8y to the negative 6, which is the same as what? That's the same as 8 times 1 over y to the positive 6. All right, 1 over y to the positive 6. And that's the same as what? You have an 8 on the top and a y to the 6th on the bottom. 8 over y to the 6th. Let's talk about dividing numbers that have different bases but the same exponent. So what do I mean? Suppose you had x over y cubed. That is the same thing as x cubed over y cubed. You cube the top and you cube the bottom. Suppose I had, suppose I had a squared over b to the 4th cubed. Well, a squared cubed is a to the 6th divided by, and b to the 4th cubed is b to the 12th. So you cube the a squared and you also cube the b to the 4th. And let's just write a very simple example. Suppose you had 2/3 squared. You apply the exponent to both the numerator and the denominator. So it's 2 squared in the numerator is 4, 3 squared in the denominator is 9, so you would have 4/9. Let's talk about fractions raised to exponents. So let me write out a few. 1/2 to the 1, of course, is just 1/2. 1/2 squared, you apply the exponent to the numerator and the denominator. So it's what? It's 1 squared, which is 1, over 2 squared, it's 1/4. 1/2 cubed, you apply the exponent to the numerator, so 1 cubed is 1, and the denominator, 2 cubed is 8. One thing you'll notice is that when you take a fraction and raise it to an exponent, the number is getting smaller, not bigger. 1/2 is bigger than 1/4 is bigger than 1/8. How about 1/2 to the negative 1? So that is 1 over 1/2 to the positive 1. It's 1 over 1/2. Well, dividing by a fraction, remember that? That's the same as multiplying by the reciprocal of the fraction, the flipped over version of the fraction. So that is 1 times, not 1 over 2, but 2 over 1. That is 2. So 1/2 to the negative 1 is 2. So when you have a fraction raised to a negative exponent, the number actually gets bigger, not smaller. 1/2 to the negative 2, same as 1 over 1/2 to the positive 2. It's the same as 1 over 1/4. That is the same as 4. So I'm taking a fraction, raising it to a negative exponent. It's actually becoming a bigger number, not a smaller number. And 1/2 to the negative 2 is the reciprocal of 1/2 to the positive 2. Same story if I raise 1/10 to an exponent. 1/10 to the 1 is just 1/10. 1/10 squared is 1 over 10 squared. 1 over 10 squared, which of course is 1 over 100. 1/10 raised to the power of 3. 1/10 cubed is 1 over 10 cubed. It's 1 over 1,000. 1/10 to the 0, anything to the 0 is just 1. But then 1 over 10 to the negative 1, you flip it over. So the rule is, if you raise a fraction to a negative exponent, instead of 1 over 10, I'm going to have 10. And instead of negative 1, I'm going to have 1. 1/10 to the negative 2. 1 over 1/10 to the positive 2. That is 10 squared. And here you see 1/10 to the negative 2 is the reciprocal of 1/10 to the positive 2. One point I want to make, I said earlier 1/2 squared is 1/4. It gets smaller, not bigger. If you take a fraction and raise it to a positive exponent, the number gets smaller, not bigger. If I were to write the number line, so here's 0, here's 1. Suppose I write 1/2 in here. 1/2 squared is 1/4. It's smaller, not bigger. So 1/2 squared. If you take a fraction and raise it to a positive exponent, the number gets smaller, not bigger. So let's write this out in general terms. My examples were 1/2 and 1/10, but suppose I wrote x over y. We know x over y to the 0 is 1. Here we just have x over y. X over y squared is x squared over y squared. All right, simple enough. But x over y to the negative 1, what do? That's y over x to the positive 1. It's just y over x. And x over y to the negative 2, you flip it over, it becomes y over x to not the negative 2, but the positive 2. So a really good thing to remember, if you see a fraction raised to a negative exponent, you flip the fraction over, you just write the reciprocal, and you negate the exponent. So the negative 2 in this case would become the positive 2. If I had 2/3 to the negative 2, that's the same as 3/2, 3 over 2, to the positive 2. So the rule, you flip the fraction and you switch the sign of the exponent. What happens if an exponent is a fraction? So suppose we know what happens when you raise a number, whether it's a positive exponent, 1, 2, a negative exponent, -1, -2. But suppose we raise it to a fraction. How about 4 to the 1/2 or 4 to the 1/3? Well, you know the value, it's going to be greater than 1 and less than 4, but what exactly is it? A fractional exponent is a root. So 4 to the 1/2 is the square root of 4. And 4 to the 1/3 is the cubed root of 4. So 4 to the 1/2 is 2. 4 to the 1/3, the cubed root of 4 is not something you need to try to memorize. But that's what fractional exponents are about. We will talk about roots in another video, but fractional exponents are really roots. Suppose you had 4 raised to the 3 over 2, 4 to the 3/2. Well, that is the same as 4 to the 1/2 cubed. You multiply the exponents. That is the same thing as 4 to the 1/2 is the square root of 4. So the square root of 4 cubed, that's the same as 2 cubed, and 2 cubed is 8. Let's apply some general rules here. We said 4 to the 1/2 is what? The square root of 4. 4 to the 1/3 is the cubed root of 4. You put the cube, the 3, inside that little divot, the cubed root of 4. So x to the 1 over b is, you would say, the b root of x. Suppose I have 4 to the 2/3. I could write that is the same thing as 4 squared to the 1/3. That is the same thing as the cubed root of 4 squared. So as a general rule, x to the a over b is the b root of x to the a. So you might see this on a harder question. Using the smallest base, what do I mean? If you see a number raised to an exponent, suppose I have 4 squared, you want to ask, can I reduce that down to a smaller number, a smaller base? Right now the base is 4, but hey, 4 is 2 squared. So this is the same thing as 2 squared squared. This is 2 to the 4th. So I've reduced 4 down to the smallest base. Suppose I had 9 squared times 9 cubed. Well, 9 squared is the same thing. 9 is the same thing as 3 squared. So that's 3 squared squared times 3 squared cubed. So 3 squared squared, that's the same as 3 to the 4th times 3 squared cubed, 3 to the 6th. So that is 3 to the 10th. That's a big number, but that is reducing it down to its smallest base. Suppose I saw an equation. Suppose I saw something like 3 cubed times 9 cubed equals 27 to the x raised to the power of x. Well, instead of comparing 3's, 9's, and 27's, I'd love to compare 3's, 3's, and 3's. I'd love to get all of these down to a base of 3. So this is the same as 3 cubed times, well, 9 is 3 squared. So 3 cubed times 3 squared cubed equals, well, 27 is 3 cubed. 3 times 3 times 3 is 27. So this is 3 cubed to the x. So what do I have here? I have 3 cubed times 3 to the 6th equals 3 to the 3x. On the left, 3 cubed times 3 to the 6th is 3 to the 9th. So 3 to the 9th is equal to 3 to the 3x. Well, if that's the case, then that means that 3x has to equal 9. 3x has to equal 9. So 9 is equal to 3x. I divide both sides by 3. X is equal to 3. So sometimes you can actually solve for a variable by taking numbers and reducing them down to the smallest base. Let's talk about some perfect squares that it's really good to memorize. You probably remember all the perfect squares from 1 to 10, but how about some bigger numbers? These are really good to memorize. 11 squared. If you forget it, the easiest thing to do, this is the same thing as 11 times 11, but that is the same thing as 11 times, you would say, the quantity 10 plus 1. And 12 squared, the same as 12 times the quantity 10 plus 2, etc. So let me write these out. 11 times the quantity 10 plus 1. So 11 times 10 is 110. We're distributing, right? Plus 11 times 1 is 11. So 121. 11 squared is 121. Really good to memorize that. 12 squared. Well, 12 times 10 is 120. Plus 12 times 2 is 24. So 144. 12 squared is 144. 13 squared. 13 times 10 is 130. Plus 13 times 3, 39. So 13 squared, 169. 14 squared. This one's a little harder to memorize. 14 times 10 is 140. Plus 14 times 4. Well, let's see. 14 times 2 is 28. Times 2 again is 56. So that is 56. So 14 squared is 196. Good to memorize. And then 15 squared, a little bit easier. 15 times 10 is 150, plus 15 times 5 is 75, so that is 225. 15 squared is 225. So these are good to memorize for standardized tests. And then 20 squared is good to memorize. That happens to be 400. So those are some perfect squares you want to memorize. How about some perfect cubes to memorize? 1 cubed is just 1. 2 cubed, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 cubed is 4 times 4 is 16. Times 4 again is 64. And 5 cubed, 5 times 5 is 25. Times 5 again, 125. So these are some good perfect cubes to memorize for standardized tests. With regard to squares and cubes, another nice thing to memorize, 4 cubed, 4 times 4 is 16. Times 4 again is 64. 8 squared is also 64. Is that just a coincidence? Well, let's see. 4 is the same thing as 2 squared. So 2 squared cubed. 8 is the same thing as 2 cubed. So 2 cubed squared. Well, 2 squared cubed, you multiply, that's 2 to the 6th. 2 cubed squared, you multiply, that is 2 to the 6th. So both equal to 64.